We already discussed about how simple linear regression works. So it works based on your straight line approach, or it works based on OLS, ordinary least square, and it works based on gradient descent. Let's try to see how exactly we are able to calculate the coefficients and intercepts in a multiple linear regression model. So now, in order to identify the coefficients and intercepts in a multiple linear regression model, let's try to understand the equation of your multiple linear. In simple, the equation of a multiple linear regression is y equal to m1 x1 plus m2 x2 plus m3 x3 plus so on and so forth mn xn plus c, where c going to be your intercept and where your m1 m2 m3 mn going to be your coefficient values. Now if there is more than one input parameter, we are able to get into our multiple linear regression. So if I want to identify multiple parameters, so we saw how exactly to calculate m value and c value if there is only one input parameter. But if there are multiple input parameters, how exactly we need to check it? So in order to do that, we need to use the equation beta cap, or we can call it as, based on above equation, I can call it as m cap. So there are n number of your coefficient parameters. In order to identify it, you need to use x transpose into x of your inverse matrix into x transpose into y. Let's try to see this simple example. Now here there are two input parameters. This is your input parameter. You have input 1 and you have input 2, and this extra one, all ones you have it, right, that going to be your intercept value, so or we can say your c value. Now what exactly intercept, you are pretty much familiar with. When all your inputs are 0, this intercept value going to be your y value in simple. So now this intercept going to be 1 here in this case. Why? We want to identify the actual intercept value. Now here there are two inputs and one extra intercept value. So overall you need to identify three parameters. So in order to identify three, the resulted matrix need to be in a format of 3 by 1 format. Now here we got your input matrix, where the input matrix dimension is there are n number of rows and there are 3 columns. So now your input size is so n by 3. Now when you transpose this n by 3 matrix, it going to be 3 by n matrix. When you are multiplying 3 by n with n by 3, the resulted matrix going to be a 3 by 3 matrix. Now once we achieve this x transpose of x, then we want to calculate a inverse matrix to it. So let's see how we calculate inverse. And before that, after calculating this 3 by 3, then we want to multiply x transpose, which going to be 3 by n, which going to be your x transpose of y going to be 3 by 1. So when you multiply it, the resulted matrix going to be 3 by 1. Now the final one, I want to do inverse. So before going for a means like inverse matrix, let's see how exactly we calculate. If you take a 3 by 3 matrix, first you calculate the det of A. So in order to calculate det of A, so you take value of A multiplied by, so you multiply E with respect to I minus H with respect to F, so that you are able to get this particular value, and then you go in a sequence of plus, minus, plus. So again you go with B, then you try to multiply D with I, and you multiply f with g. So now, and you subtract these two values and these two values, and after doing that you take again plus c value, then d multiplied by h minus g multiplied by e. By doing that you are able to get det of A. After calculating det of A, then you need to calculate matrix of minus. So where exactly you are calculating m1. So matrix of minus going to be in simple m matrix, I'm just writing it as m, equal to the position going to be m11, m12, m13. In this we are able to calculate. So in order to identify m11, if you are able to take this value is one of the matrix of minor m111. In this way we are, if I am going with m21, then it going to be A multiplied by if I'm going with this one, then it going to be D and I, H and C. In this way we are able to calculate matrix of minus, so which going to be det of this particular values. So once we calculated matrix of minus, then if you are able to allocate plus, minus, plus, this kind of notations if we allocate to the matrix of minus, then we call it as a cofactor matrix. So once we achieved the cofactor matrix, this is going to be C11, C12, C13. In this way we got C, what is that, cofactor. Once we achieved cofactor matrix, if you are able to do transpose of that particular cofactor cofactor matrix, then we are able to get an adjoint matrix. After getting adjoint matrix, you are able to identify inverse matrix. So how exactly you calculate inverse matrix? In simple, 1 by det of A into adjoint of A. By doing it, you are able to get a 3 by 3 inverse matrix. Now we are doing this inverse matrix for x transpose of x, so which is a 3 by 3 matrix. For that, the same procedure we do, so that we get x transpose of x inverse matrix. The result is also going to be 3 by 3. Once you achieve this matrix, then what you are doing, you are multiplying that with x transpose of y. Now this x transpose of x of inverse going to be 3 by 3 dimension, and x transpose of y dimension going to be 3 by 1. The resulted going to be 3 by 1, so that you are able to get two coefficient values and one intercept value. If there are like 10 means like input parameters, then you are able to use your input parameter size. So like in order to create this, your input size going to be 10 plus 1. So 1 is for your intercept value, and another 10 value going to be for your coefficient. So this is how your multiple linear regression works, and the theory wise, and the same assumptions of whatever you saw it in simple linear, the same assumption work even for a multiple linear. And coding, it's as simple as same as like your simple linear. Instead of passing one input parameter, so you try to take multiple input parameters so that you get multiple coefficients and one intercept value. I hope you got it clear. Thank you so much, and see you in our next video.